All right, so today we are going to be talking about chords. So you should have received this yellow handout. You can fold it like you see it. And this is in section 10.3 if you're using your textbook online or if you're using the journal workbook. So again, today is all about chords, and if you recall, a chord is a segment inside the circle whose endpoints are on the circle. And the most popular chord is the diameter. Okay, so let's start with the congruent corresponding chords theorem. It states that in the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so what we're saying here is that arc AB is congruent to arc CD if and only if chord AB is congruent to chord DC. So that is the congruent corresponding chords theorem. Again, pause the video as needed. Let's take a look at the perpendicular chord theorem. This states that if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So the key word here is bisects. So let's recall what bisect means. Bisect means it's going to cut something in half. So if EG, segment EG, is a diameter, and segment EG is perpendicular to a chord FD, then we have two things we can say. We can say that that chord FD is cut in half, bisected. So we can say that HD, segment HD, is congruent to segment HF, so we can show that they're congruent by putting our little dashes there. And their corresponding arcs are congruent, so we can say that arc GD is congruent to arc GF. And again, we can put little dash marks through those arcs to show that they are congruent. And then we have the converse of that. So if you recall, converse is just when you take your if and then statements and you switch them. So if one chord of a circle is a perpendicular bisector of another chord, then the first chord is a diameter. So what this is saying is if segment QS is perpendicular bisector of chord TR, then chord QS is a diameter. So let's go ahead and take a look at some examples using these three theorems. Okay, example 1. In the diagram, circle P is congruent to circle Q. So circle P and circle Q are congruent, and that's shown here by showing that they have congruent radii. We're given that segment FG, which is a chord, is congruent to segment JK, which is also a chord. We're also given the measure of arc JK being 80 degrees. Find the measure of arc FG. Okay, so because we have congruent circles and they have a pair of congruent chords, that means that their corresponding arcs are also congruent. So the measure of chord FG is also 80 degrees. Example 2. We're given circle M here, and we have some things that are labeled a little bit. We are told that diameter, or chord, well, what's a diameter? JL, because it's a chord that passes through the center of M. Diameter JL is perpendicular to chord HK. We know it's perpendicular because we have that right angle there. So if we have a diameter that is perpendicular to a chord, that means that the diameter bisects the chord and it bisects its arc. Okay? So that means if NK is 7, that HM is also 7. And that means that arc JH is the same as arc JK. I'm just going to mark those as congruent. So part A, find segment HK. So H to N is 7, N to K is 7, 7 plus 7 is 14. Part B, again, we know that these that this large arc, HK, is being bisected by the diameter. So we know that HJ has to equal JK. So 11x is equal to 70 plus x. So we're going to solve for x. We're going to subtract x from each side. Get 10x is equal to 70. Divide by 10 and we get x is equal to 7. Just a coincidence that these are all 7s. But the directions ask us to find the measure of arc HK. Well, we know it's going to be 11x plus 70 plus x. So that's 12x plus 70. And we now know what x is. X is equal to 7. So we have 12 times 7 plus 70. So that is a measure of 154 degrees. Example 3. Excuse me, had to sneeze. Okay, we're given that the measure of arc AC is 150. Find the measure of arc AB. Okay, so we have a pair of congruent segments. AB is congruent to BC. Those are chords. So therefore, their corresponding arcs are also congruent. We don't know what those arcs are, so we'll just call it X. So this one would also be X. But we do know that one whole time around the circle is 360 degrees. So we have X plus 150 equals that total of 360. So we have 2x plus 150 is equal to 360. Subtract your 150. 2x is equal to 210. Divide by 2. And x is equal to, what is that? 105? Which means that the arc of AB is 105. Coming up here, the equidistant chords theorem. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So equidistant just meaning that they are the same distance from the center. So we can say that chord AB is congruent to chord CD if and only if they are equidistant from the center. So that means that EF would have to be congruent to EG. And because we're talking about a distance, you will see that that distance also has to be perpendicular. So let's take a look at example 4. It says in the diagram, QR is equal to ST, which is equal to 16. So QR is 16, ST is 16. CU is 2x, and CV is 5x minus 9. Find the radius of circle C. So, if QR and ST are both chords and they are congruent chords, that must mean that they are the same distance away from the center. So we can say that CU and CV are congruent. So 5x minus 9 is equal to 2x. I'm going to subtract 5x, so I get negative 9 is equal to negative 3x. So x is a positive 3. So that means that CU is 6. What I'm going to do, I'm going to just draw a little segment here. This is U, this is C. So this is 6. Okay. What we are trying to find is the radius. Well, let's take a look right here. If I connect C to Q, I now have a right triangle. So I want to work with this right triangle here. So let me draw this here. Okay. And we know that QR is 16. So if QR is 16, that means that QU is half of that, which is 8. So there's 8. So now we can find CQ, we'll call it R for radius, by doing the Pythagorean theorem. So again, we want the hypotenuse to be on the side by itself, so we have R squared. That's equal to leg squared plus leg squared. So we have 6 squared plus 8 squared. So R squared is equal to 36 plus 64. 36 plus 64 is 100. Take the square root and we get 10. So that is our radius. I'd like for you to try example 5 on your own. It's the same idea. Pause the video while you work through example 5. If it helps to draw a separate triangle, go ahead and do that. So go ahead and pause and work through example 5 on your own. You should get R equals 15. So again, we know that LM is a chord and JK is a chord, and those two chords are congruent. Therefore, they must be equidistant from the center. So that means that 3x has to equal 7x minus 12. So that's my first step. There's my equation. I found x to be 3. I know I need to find a radius, so I drew a line from the center to a point on the circle, giving me this right triangle. So this is N, P, and K. So NP is 3x, so 3 times 3 is 9. JK is 24, so half of that is 12, so PK is 12. Then we're trying to find that radius NK. So again, R squared equals 9 squared plus 12 squared. So you get 81 plus 144, which is 225. And take the square root of 225, so R is 15.